Alright, so in this video, we're going to go over trigonometric identities. Now, for the identities, there are three identities you need to know. The first identity is that sine squared x, or theta, or any variable, plus cosine squared x is going to be equal to 1, right? And the other identity is that tan squared x plus 1 is equal to cosecant squared x. And the third identity is that cot squared x plus 1 is equal to, this is going to be secant squared x, and this is going to be cosecant squared x. So let's look at how we can derive these formulae. So let me show you here. So suppose we have a triangle, a right angled triangle. There are other ways to derive this, but let's use a right angled triangle for now. And we'll call this angle x. Now that we have this angle x, this side I will call O to be opposite of this angle. This side will be A, adjacent to this angle, and this side will be H, the hypotenuse, which is always going to be opposite to your right angle, right? Now that we have these three, we know that A squared plus O squared is going to be H squared. And this is what we call the Pythagorean identity, right? This is the Pythagorean theorem. And now, for step 1, or for the formula 1, you divide by h squared. So if we divide by h squared, we have a squared by h squared plus o squared by h squared is equal to 1. And I can rewrite this as a over h squared plus o over h squared is equal to 1. And what is a? A is adjacent over hypotenuse. And adjacent over hypotenuse, well, adjacent over hypotenuse is just cosine squared x plus opposite over hypotenuse is just sine squared x is equal to 1. So that is how you get the first formulae. And step 2 is divide by a squared. And if I divide by a squared, I get 1 plus o squared by a squared. So I am dividing this equation by a squared. O squared by a squared is equal to h squared by a squared. Alright, so I have 1 o over a squared equal h over a whole squared. So I'm just simplifying the expression. 1 plus, what is o over a? Opposite over adjacent. Well, that is tan squared x. And h over a, hypotenuse over adjacent, is going to be secant squared x. So that is how you get your second identity. And for the final identity, we divide by o squared. And if I divide by o squared, no, this is not a squared factorial, by the way, it's just a squared. Divide by o squared. So now let's divide by o squared. I get a squared over o squared plus 1 is equal to h squared over o squared. And I can rewrite this as a over o squared plus 1 is equal to h over o squared. Alright, so adjacent over opposite, that is just cot squared x plus 1. And h over o, hypotenuse over opposite. Hypotenuse over opposite, that is going to be cosecant squared x. So that is how you get your three trigonometric identities. Alright, so now that we have our identities down, let's go over some questions. So I know there are like questions 1 to 4. They deal with solving trigonometric equations, and we are going to tackle that in a future video, not in this one. So this one, we'll just prove these identities, we'll simplify, and just work with these. All right. So there is this question 5. I know it's not in the screenshot, but let me write it out for you. Question 5 says, I think it says something along the lines of, write in terms of x, in terms of sine x, and the equation that we have to write in terms of sine x is 2 sine squared x minus 7 cosecant squared x plus 4. And how do we write this in terms of sine x? Well, 2 sine squared x, I don't have to worry about this term because it's already in terms of sine x. My second term is just going to be 7. Cosecant is the reciprocal function of sine. So cosecant squared x is just 1 over sine squared x plus 4. And let me just quickly show you why. Remember, 1 over cosecant x is equal to sine x, right? So if I square both sides, sine squared x is just going to be this side squared, which is just 1 over cosecant squared x is equal to sine squared x. And you can just switch these. So 1 over sine squared x is going to be cosecant squared x if I just cross multiply, right? If I send this to the other side and bring sine squared x to the denominator. So that is just the substitution that we have made here. All right, now you might be wondering, well, this does not match the answer given in the textbook. Well, the answer given in the textbook is actually for a different function. So the question, if you want to match the textbook, the question should be 2 sine squared x minus 7 cos squared x plus 4. And now if you start simplifying this, you get 2 sine squared x minus 7. Now what is cos squared x? Remember, sine squared x plus cos squared x is equal to 1. So cos squared x is going to be 1 minus sine squared x. And I am sometimes going to substitute this directly. So 7, 1 minus sine squared x plus 4. Now let's simplify further. We have 2 sine squared x minus 7 plus 7 sine squared x plus 4. And if you combine 2 sine squared x plus 7 sine squared x, that is 9 sine squared x. And minus 7 plus 4 is minus 3. All right. So you're going to get something like this. So this is, if you say sine squared x is equal to u, then you can write 9u minus 3. So that also works. All right. So that is the expression that is sort of similar to the expression that they want in the textbook. But yeah, the question as it is, you can only simplify it to this expression. All right. So now let's start with question 6. Question 6 says, prove each of these identities. Cos x times tan x is equal to sin x. All right, well, I keep cos x as it is. Tan x is just sin x divided by cos x, right? And we are working with the left-hand side. And this cos x in the numerator and the denominator cancel out, leaving me with just sin x, which is exactly the right-hand side. So we are done. 1 minus cos squared x over sin x cos x. Now, if you remember, sine squared x plus cos squared x was equal to 1. So 1 sine squared x is going to be 1 minus cos squared x. And that is 1 minus cos squared x is exactly what we have in the numerator here. So the numerator here is going to become sine squared x, and the denominator we have sin x cos x. So sine squared x is just sin x times sin x, right? So one of these cancel out. And then I have sin x over cos x, which is tan x, which is exactly the right-hand side. So we are done. All right, so let me erase this as we go. So I hope this was clear, because I need more space. All right. Question 3. Sin x plus cos x cot x is equal to cosecant x. All right, so a bit more difficult. So I have sin x plus cos x cot x. And I need to write this, show that this is equal to cosecant x. All right, so my left-hand side is sin x plus cos x cot x. Sin x, let me keep as it is, plus cos x. Cot x can be written as cos x over sin x, right? It's the reciprocal of the tan. It's the reciprocal of tan x, and tan x is sin x over cos x. So cot x would be cos x over sin x. All right, so I have sin x plus, if I simplify this, I get cos squared x over sin x. Now let me write this with the common denominator. So here, this expression, I will multiply by sin x, and I will divide by sin x. Remember, sin squared x divided by sin x is sin x, which is what we have here. And then now I can add these things together. Sin squared x plus cos squared x over sin x. And the numerator simplifies to 1 over sin x. Because sin squared x, this identity simplifies to 1. And then this gives me cosecant x. So which is what we needed. So we have proven. So this is what we wanted, and we've done it. All right. Part D. And I don't know why. My screen keeps on lagging these days. So I have cosecant x minus sin x on my left-hand side. I'm going to work only with my left-hand side. Cosecant x is just 1 over sine x. So usually, I like to write things in terms of sine, cos, and tan. Or just sine and cos. Alright, I'm so sorry. Okay, yeah. 1 over sine x minus sine x. Alright, so now let's write this with a common denominator. 1 over sine x, I'll keep as it is. And I will multiply and divide by sine x here. Note that sine x and sine x will cancel out, leaving me with only this sine x. So I'll get sine squared x divided by sine x. And now I can write this in terms of a common denominator, like this. And now, 1 minus sine squared x. If you remember the identity, sine squared x plus cos squared x equal to 1, you will notice that this numerator simplifies to cos squared x divided by sine x. And I can write this as, I keep 1 cos x, and I write it as cos x over sine x. And this simplifies to cos x times cot x, which is exactly what we have on the right-hand side. And we are done. All right. Part E. We have secant x, cosecant x minus cot x. So secant x, cosecant x minus cot x. That is the left-hand side for part E. So secant x, I can write it as 1 over cos x. And cosecant x, I can write it as 1 over sine x. Minus cot x, I can write it as cos x over sine x. So my first term simplifies to 1 over sine x cos x, and my second term is just cos x over sine x. Now if I want a common denominator, I need to multiply and divide by cos x. So this is sine x cos x, and this becomes sine x cos x. So I will have 1 minus cos squared x in my numerator, and I will get sine x cos x in my denominator. Now how do I get this? Well, this simplifies to cos squared x, and now that I have the same denominator, I can put the things together. 1 minus cos squared x is sine squared x divided by sine x cos x. And now I can cancel out one of the sine x, and sine x divided by cos x finally gives me tan x. So that is how you get tan x for part E. Alright, part F. Cos squared x over 1 over, okay, so left-hand side is very simple. Cos squared x over 1 minus sine x. I can write the numerator, cos squared x is 1 over sine squared x, right? 1 minus sine x. And if you remember, a squared, so because I can write 1 as 1 squared minus b squared is just a plus b, a minus b. So using that, I can write the numerator as 1 minus sine x, 1 plus sine x, right? Divided by 1 minus sine x. And this cancels out, leaving me with 1 plus sine x. Alright. So we are done with F. Now let's do G. I have 1 plus secant x. And I have cosecant x minus cot x. That is my left-hand side. Alright. So this one, I can write it as 1 plus 1 over cos x, right? And this one, I can write it as 1 over sine x. This as in cosecant squared x. Cosecant x, I can write 1 over sine x minus cot x is just cos x over sine x. Alright, so secant x is 1 over cos x, cosecant x is 1 over sine x, cot x is this expression. Alright, this one, if I write with the common numerator, a denominator, I have to write it as cos x plus 1 divided by cos x, right? I multiply and divide 1 by cos x, and then I write it as a common denominator, like this. And this part, I can write it as 1 minus cos x over sine x. Alright, so if you remember, I have this one I can rewrite as 1 plus cos x. And I have 1 minus sine x here, right? I just switched the order. Cos x plus 1 is equal to 1 plus cos x. Alright, 1 plus cos x, 1 minus cos x is going to be 1 minus cos squared x. It's the same formula. A squared minus b squared is equal to a plus b, a minus b. We have 1 plus a plus b here, a minus b here. So that is why I can simplify it in the form of a squared minus b squared, 1 minus cos squared x. Alright, divided by cos x sine x. And now this I can write it as sine squared x divided by cos x sine x. And sine squared x and sine x. So sine squared x is just sine x times sine x, and one of them cancels out with the denominator. And finally, I get tan x. All right, which is what we needed on the right-hand side. Okay. Now for part H, I have this expression, this very ugly looking expression, and the question is incomplete. So we'll just leave it. We have nothing here. It has to be cos of something, right? It can't be just cos. And let's think about it. Yeah. So if you just want to write in terms of cos, you can write it as cos to the power 4x plus sine squared x is just 1 minus cos squared x times cos squared x. And that is just cos 4x plus cos squared x minus cos to the power 4x, right? If you simplify, if you expand. And these things cancel out, so you just get cos squared x. So I think that's what they want, but the question is incomplete. All right. So question 7 says prove each of these identities. So we'll just work with the left-hand side. For 7a, we have sine x plus cos x squared. I'm doing 7a. So if you expand this, I get sine squared x plus 2 sine x cos x. If you remember your binomial theorem, and if you don't, please go back and check the videos from chapter 2. Sine squared x plus cos squared x is 1 plus 2 sine x cos x. And we're done. So sine squared x plus cos squared x is 1, and then we have this. And that is exactly the right-hand side. So we are done. Part B, we have 2, 1 plus cos x. We only work with the left-hand side, minus 1 plus cos x squared. All right. So this is just, if you multiply 2 inside, you get 2 plus 2 cos x. If you expand this bracket, you are going to get 1 plus 2 cos x plus cos squared x. All right. Okay, I'm sorry. Plus cos squared x, right? And again, if you don't know how to expand this, I encourage you to either do it manually or go back to the videos from binomial theorem. So you have 2 plus 2 cos x minus, and now let's just distribute the negative. 1 minus 2 cos x minus cos squared x. All right. So 2 cos x minus 2 cos x will cancel out. 2 minus 1 is just 1, right? 2 minus 1 is 1 minus cos squared x. And that is just sine squared x. And we were doing, I think, 7b. Yeah, 7b is sine squared x. All right, let me erase everything because the image moved. All right, so we are done with 7a and 7b. Let's look at 7c. So we have 7c, which is 2 minus squared. I think this is the left. Is there a way to lock this? Let me think. Oh yeah, we can lock images. Okay, I'm figuring it out today. All right, 2 minus this expression. So I can write this as 2 minus, expand this bracket, and you get sine squared x plus cos squared x plus 2 sine x cos x. All right, 2 minus sine squared x plus cos squared x is 1 plus 2 sine x cos x. All right, 2 minus 1 is just 1, and you distribute the negative sign, you get 2 sine x cos x. This negative is for both the terms, right? All right, now I can write this 1 as sine squared x plus cos squared x minus 2 sine x cos x. I can rewrite this as sine squared x minus 2 sine x cos x plus cos squared x. And this is just sine x minus cos x whole squared. All right, and that is, I think, the right-hand side. Now, how do I know this simplifies to this? Well, if you remember, a squared minus 2ab plus b squared is equal to a minus b squared. We discussed this in chapter 2. Then you can sort of understand how we got from here to here. All right, so we are almost done with question 7. And let's do (7D). So 7D says cos squared x minus 2 squared is minus 3 sine squared x. So this is the left-hand side, LHS. Now, we need to simplify this. This becomes cos 4x. If you expand this, I'll leave the expansion to you, but if you expand this bracket, you get cos 4x minus 4 cos squared x plus 4 minus 3 sine squared x. All right. Now, if you think about it, right? Cos 4x minus 4 cos squared x. This 4 can be written as 4 times 1. And what is 1? 1 is just cos squared x plus sine squared x minus 3 sine squared x. All right. So now if you simplify this further, minus 4 cos squared x plus 4 cos squared x is going to cancel out. So you have 4 sine squared x minus 3 sine squared x left. And this is going to simplify to cos 4x plus sine squared x, which is exactly what we have in the right-hand side. And we are done. All right. Question 8 says, now we're not going to do all of them because I think now that you have enough ideas. So 8a, just because our right-hand side is in terms of cos, substitute sine squared x as 1 minus cos squared x, and you'll get your answer. All right, 8b. Because we have sine squared x here, substitute cos squared x as 1 minus sine squared x, and you'll get your answer. All right, so fairly, very, very simple here. Well, tan squared x is just sine squared x over cos squared x, right? Minus sine squared x. Now write your second term. Okay, let's do 8c. Let's see. Okay, let's do 8c and d. All right. 8c says, so for 8c, on my left-hand side, I have tan squared x minus sine squared x. I can write this as sine squared x over cos squared x minus, and if I want to make a common denominator here, I multiply by cos squared x and I divide by cos squared x. So remember, this and this will cancel out, leaving me with only sine squared x that I started with. So I can factor out sine squared x from my numerator. So I join a common numerator and I factor out sine squared x, and I will get 1 minus cos squared x divided by cos squared x as my denominator. And I'll leave you to think about how I got from here to here. It's fairly simple. You have sine squared x minus sine squared x cos squared x in your numerator. We have cos squared x in my denominator, and I can factor out the sine squared x. 1 minus cos squared x is also sine squared x over cos squared x. All right. So now let's just look at what we need to simplify it to. We need to simplify it to this. So this expression, sine squared x divided by cos squared x, is just tan squared x. And we are done. Okay, part D. Cos 4x plus sine squared x is what we have on our left-hand side. I can write cos 4x as cos squared x squared plus sine squared x, right? And I can write this term as 1 minus sine squared x squared plus sine squared x. Now if you expand this, you get 1 minus 2 sine squared x plus sine to the power 4x plus sine squared x. All right, and if you simplify this further, minus 2 sine squared x plus sine squared x gives you minus sine squared x plus sine 4x. Now remember, 1 minus sine squared x, minus 2 sine squared x plus sine squared x is minus 1 sine squared x, which we have here, and 1 minus sine squared x is cos squared x. And we are done. This is what we have here. All right, question 9. So we are not going to do all of them. This is fairly simple. You just use a minus b times a plus b is equal to a squared minus b squared. All right, so we have a squared minus b squared in the numerator. You just write this as cos x plus sine x, cos x minus sine x, and cos x minus sine x, and this will cancel out, so you get this on your right hand side. All right, so that is how you do A. For B, is also fairly simple. This one, you can write it as, well, sine squared x squared minus cos squared x squared, right? This side, left-hand side, I can write it like this. And this is also the difference of squares. So I can write it as sine squared x minus cos squared x and times sine squared x plus cos squared x. And this second part simplifies to 1. So anything times 1 is that thing. So I have this thing left. And now, because my right-hand side is in terms of sine x, I can just substitute 1 minus cos squared x is equal to 1 minus sine squared x. And if you simplify this, you get your right-hand side. So we are done. All right. Part C. Part C is also fairly straightforward. So I'm going to do C here. We have cos 4x minus sine to the power of 4x divided by cos squared x. All right, so let's sort of distribute this. Let's distribute the denominator. So I will get actually, we can use the same trick that we used here because it's the same thing here, right? So I can write my cos 4x minus sine to the power of 4x. So I can write my numerator as like this. And cos squared x squared is cos to the power of 4x, sine squared x squared is sine to the power of 4x. And I can use the difference of squares. So cos squared x minus sine squared x times cos squared x plus sine squared x divided by cos squared x. This simplifies to 1, right? And now we just have cos squared x minus sine squared x divided by cos squared x. And this will simplify to 1 minus tan squared x. It's pretty obvious. All right, and that is what we needed. We're done with C. Part D is quite similar. We have cos x divided by tan x times 1 minus sine x. That is your left-hand side for part D. Tan x, I can write it as sine x over cos x, 1 minus sine x. All right. Now, what I can do is I am dividing this is going to simplify to this. Now, how does this simplify to this? Well, I can think of this part as follows. I have cos x, and I'm dividing it by sine x over cos x. And that is the same, and then I'm multiplying by this, 1 minus sine x. And this part, right, let me change colors here. This part I can think of as I have cos x times the reciprocal, right? Dividing by a fraction is the same as multiplying by its reciprocal. Cos x over sine x times 1 over 1 minus sine x. All right, and if you put everything together, you get this, as I mentioned before. And now that we have this, I have cos squared x over sine x 1 minus sine x in my denominator. And cos squared x, I can write it as 1 minus sine squared x. And this is 1 squared minus sine squared x. So I can write it as 1 minus sine x, 1 plus sine x, divided by sine x, times 1 minus sine x. And this is going to cancel out. So finally, we have, we have 1 plus sine x over sine x, which is identical to 1 plus 1 over sine x, if you simplify. All right, so we are done with D. How do you solve E? Well, E is fairly simple. You divide numerator and denominator by sine x. Sorry, by cos x. Why does this work? Well, let me show you. Sine x minus cos x over sine x plus cos x. You divide by cos x in the numerator, right? Over cos x, this is my numerator, divided by, so basically, if you divide the numerator and the denominator by same thing, when you actually simplify it, this cos x and this cos x will cancel out. So you're not changing anything. All right. Now, if you simplify the numerator, you will easily see that you have tan x minus 1. And if you simplify the denominator, you will easily see that you have tan x plus 1. All right. And that is what we have on the right-hand side anyways. Okay. Now part F, we have 1 over sine x minus 1 over tan x squared. And we need to show that it's the right-hand side. All right. 1 over sine x, 1 over tan x is cot x, right? And cot x is just cos x over sine x squared. And this will simplify to 1 over cos x over sine x squared. So we have 1 minus cos x squared divided by sine squared x. But sine squared x can be written as 1 minus cos squared x. Right? Denominator, we have sine squared x. That can be written as 1 minus cos squared x. And now I can simplify this, because this is 1 squared minus cos squared x. So I can write it as 1 minus cos x, 1 plus cos x. All right. Sorry. And we don't have, this is just 1 minus cos x squared. So one of these are going to cancel out, right? Because 1 minus cos squared x is just, the whole squared here is just 1 minus cos x times 1 minus cos x. So one of them cancels out. And we have 1 minus cos x over 1 plus cos x. That is exactly what we have on the right-hand side. All right. Part G. We have tan x plus 1. Tan x plus 1 divided by sine x tan x plus cos x. All right. In the right-hand side, we only have sine and cos. So let's write everything in terms of sine and cos. So we have sine x over cos x plus 1 divided by sine x times sine x over cos x plus cos x. All right. Now let's make a common denominator. So the numerator becomes sine x plus cos x divided by cos x. This is the numerator here, because I wrote 1 as cos x divided by cos x. And I'm allowed, because cos x divided by cos x is just 1, right? So I multiplied and divided by cos x. And my denominator is sine squared x divided by cos x. And this term, if I want a common denominator of cos x, I have to multiply by cos x and I have to divide by cos x, right? So that gives me cos squared x divided by cos x. And if you put everything together, you will just have sine squared x plus cos squared x divided by cos x. That is going to be your denominator. Now sine squared x plus cos squared x, that is 1. And this cos x and this cos x will actually cancel out. So eventually, you are only left with sine x plus cos x. And that is the solution for G. All right. H is very simple, so I'm going to leave you to try. 1 minus cos squared x is sine squared x. 1 minus sine squared x is cos squared x. Your numerator becomes sine to the power of 4x. Your denominator becomes cos to the power of 4x. And this is just tan to the power of 4x. All right. And yeah, I think I'm going to call this is going to be it for this video. And we're going to solve more identity related questions in the next one.